Right. So yeah, we have already done about the common emitter, common collector amplifier, and common source amplifier as well. Of course, all of you have done a really good job, right? So I have left the derivation, and yeah, most of you have submitted, except a few. And yeah, you guys have done a really good job, right? So I'm planning to do like this, right? So I will just explain the concepts, and I'll stop somewhere. You can continue with the basic mathematical derivations, so that it will be helpful to you as well, right? So it will be like you will be practicing the questions, and it will be serving my time from spending a lot of time for um, uh, solving mathematics as well, right? For common source amplifier, 15 of you have submitted your assignments except 3, right? Yeah, and then common collector amplifier. Yeah, again, 15 of you have submitted except 3, right? And yeah, you guys have done a really good job, and I'm enjoying marking your assignment sheets, right? So we have seen common source amplifier, right? Now, the final amplifier configuration in this section is source follower amplifier, right? Source follower field effect transistor amplifier is nothing but, yeah, we have a N channel FET, right? And then we have VDD. This will be my V out, right? Of course, I have an output filtering capacitor. This will be grounded. My load resistance. Then here, previous, as we seen earlier, we will have a bypass, a biasing resistors, right? Let this be R1 and R2. Similarly, here we are going to have RS and Vs, right? So here I'm going to have my input filtering capacitor, right? So this is the circuit of a common drain amplifier or source follower amplifier, right? Common drain amplifier or a source follower amplifier, right? Sometimes you may have the circuit without this R1, right? Only you will have a biasing capacitor of R2, depends on your problem. But anyhow, when compared to the internal circuits and RL and RS, R1 and R2 or parallel combination of R1 and R2 will be much higher, right? Much higher. So now we are going to draw the equivalent circuit of this field effect transistor, right, of this circuit. First, let me draw the uh, uh, equivalent circuit of a FET, and then I will complete the external circuit, right? So yeah, I have my CGD, and then CGS, right? So this will be my source, and then I am going to have my GM into VGS, right? And then I'm going to have RD, right? So this will be my transistor. So this will be my drain, source, and gate. Now I'm going to draw the external circuit. I'm going to draw the external circuit. Yeah, before drawing the equivalent circuit, what you have to do is you need to short circuit all the capacitors, and then you need to ground if you have any DC current sources. So this will be grounded and this will be grounded. So as again, so ground, 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 I would say, right? So you can make R1 and parallel R2. So this becomes R1 parallel R2, right? So yeah, I'll complete now, right? So this will be your drain, source, and gate, right? So your drain is directly connected to ground, right? So here, so that is directly grounded. There is no resistance. Sorry, I think I wrote mistake. Right? There is no resistance, that is directly grounded. And then from source, you have your RL, and then it is grounded. Right? From gate, you have R1 parallel R2, and then it is grounded. Right? This will be R1 parallel R2. Similarly, you have RS, BS, and that is grounded, right? So I would connect these three together as they are equipotential lines, right? Equipotential lines. Now I can neglect this one. I can neglect R1 parallel R2, and now, okay, let me draw the simplified circuit, right? Okay, so this becomes, of course, this is grounded, right? So this is grounded. So what I can do is, right, again, similar to your common collector amplifier, right? If this is grounded, simply I can say that this is grounded and this is grounded. Now this is also grounded. Am I right? If this is grounded here, I can simply remove all of them, and I would say, yeah, this RD is grounded, VGS is grounded, and then CGD is also grounded. Am I right? So now I am going to bring RD, VGS, and then this CGD here, right? So this RD will be somewhere here, and then this GM into VGS, but the direction will change from bottom to top when I am changing it from, or when I am just simply folding upside down. And if I bring this ground here, so I have my CGD here, and then simply this will be straightened. So this will be my VGS, and that becomes a cross input and output, right? So similar, if I draw the circuit, I would say yes. So R1 parallel R2 gone. So here I'm going to have RS, VS, right? And then of course CGD, this will not be there. So I'm going to have my CGD, and then this CGS will be across these two, right? CGS, and then of course, right, this will be straightened, and here I am going to have my GM into VGS, right? So now my VGS is actually the voltage across the CGS, right? So GM into VGS means here comes my VGS, right? And then I can simply extend it. I will have my RD and RL, or simply I can make it as ZL, right? And this will be my V out, right? My ZL equals RD parallel RL, right? RD parallel RL, and this will be my final equivalent circuit, right? So what I am going to do is I am going to solve it, which is similar to your common collector amplifier. So I am going to take this point and this point, right? I am going to apply Kirchhoff's current law at these two nodes, right? So current, let this be I1, I2, I3, right? So I3 will be here, so I3, I4, and this one will be IL, right? IL. I can simply apply Kirchhoff's, or let this be point A and point B, right? If this is grounded, as we seen earlier, the voltage at this point will be V out, and VB is equal to V out, and VA is equal to V out plus BGS, right? All the derivation is similar to your common collector amplifier, right? So now we'll start by writing the equations, right? We can start with the equations. So I would say, okay, we'll apply Kirchhoff's, right, I can see it. So you can see the circuit diagram, no? Now apply Kirchhoff's current law at this node, right? So first apply KCL at A, right? KCL at A, right? So I would say I1, right? I1 minus I2 minus I3 equal to 0. Am I right? It is going into the node, and these two are leaving from the node. So I would say I1 minus I2 minus I3 equal to 0. I1, I would write it as Bs minus Va divided by Rs. Am I right? So I1 would be Vs minus Va divided by Rs minus I2 will be, right, Va divided by 1 over j omega CGD. Am I right? 1 over j omega CGD. So I would say minus Va divided by 1 over j omega C GD. Clear, right? And then minus I3 will be VGS divided by 1 over j omega CGS. Am I right? So VGS divided by 1 over j omega CGS equal to 0. Right? So this is equation 1. Now we'll simplify it, right? From this equation, I would say, right, V equals V out, right? And then VA equals VB plus VGS, that is V out plus VGS, right? VA equals V out plus VGS. Now substitute this one here and make it as a whole equation, right? So remove this one and we'll try to simplify the equation, right? So substitute VA here, so I can write it as VS minus V out minus VGS divided by Rs minus Va will be directly this one, V out minus VGS divided by 1 over j omega, 1 over j omega GT minus VGS into 1 over omega CGS is equal to 0. Now I can group V out together, Vs together, and VGS together, right? So I would say there are no other VSs, so I have only one mm, Vs by Rs, right? Minus, and then okay, let me group V out together, right? V out into, here I have minus already there, so this becomes 1 over Rs, and here I have 1 over j omega c GD, so plus j omega c GD. Am I right? So V out and V out, and there are 3 VGSs, right? So minus VGS all minus, right? This is minus, 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 right? So here if I substitute minus, so there are no multiplications, so that will be directly minus, so I would say plus, right? So yes, I can write it something like this. Okay, don't confuse it, right? So here VGS, so I have to multiply each separately, so that becomes minus VGS, right? So minus VGS into 1 over Rs here, plus here j omega c GD, here j omega c GS, right? So I would say j omega, right, into okay, I'll write into CGD plus CGS, whole thing is equal to 0, right? I would say I'll put it here, right? The whole thing is equal to 0. I would bring this one the other side, right? Vs over Rs, right? This one the other side, right? And then I can make it equal, and this becomes plus. Am I right? Clear, right? So I remove this one. So Vs over R is equal to V out into 1 over Rs plus j omega c GD plus VGS into 1 over Rs plus j omega c GD plus CGS. This, okay, keep this as equation 1. Now apply KVL at, sorry, Kirchhoff's current law, KCL, right? Apply KCL. Right, I would say apply KCL at B, right? At B, KCL at point B. So I would say I3 plus GM into VGS is equal to IL. Am I right? So if simply if I start from here, okay, so this will be I3, this will be GM into VGS, and this will be my IL. So simply this one plus this one is equal to this one, right? These two are incoming currents at this node, and IL is the outgoing current, right? So I would say I3 plus GM into VGS is equal to IL, right? I3, simply I can write it as VGS over j omega CGD, right? VGS over 1 over j omega GS, 1 over j omega CGS, right? Plus GM into VGS is equal to IL equals V out divided by Z, right? V out into 1 over Z, am I right? So 1 over Z I can write it as, yeah, 1 over RD plus 1 over RD. So 1 over Z could be written as 1 over RD plus 1 over RL. Am I right? So simply substitute that one here. So I would say VGS into, right? So this go on top, GM plus J omega C GS, right? So J omega C GS equal to V out into 1 over Z becomes RT RL divided by RT plus RL. Similarly, as we did earlier in our common emitter amplifier, when compared to GM, J omega CGS is much smaller. Right? J omega CGS is much smaller. So I could say that GM into VGS, right? So this can be neglected, is equal to V out into this one, right? RD RL divided by RT plus RL. Now we have two equations. One is this one, right? But what we need is V out by Vs, right? So our gain AV equals V out by Vs, right? V out by Vs. So instead of VGS, substitute VGS equals V out into RDRL over GM into RD plus RL. Sorry, right? So the whole thing. So substitute VGS here and then make it in this form and do the same thing, right? So write down the equation in the form of AV mid divided by 1 plus J omega over omega H, right? J omega over omega H. What you have to do is, this is simple mathematics, right? Substitute V out VGS as V out into the whole thing here. So instead of this VGS, you will have a V out term and then take all V out together, bring it to the other side and then make it upside down. You will end up with an equation which is in the form of AV mid by 1 plus J omega over omega H. So you can simply solve the upper cutoff frequency equation, right? So okay, I leave the simplification, mathematical simplification for yourself, right? I don't think it's a complicated one, right? So you can finish it, and with that, our whole first unit is over, right? We have another 4 more units. Clear, right? So that's why I was